Okay, calculus, let's talk about 10.1, all the conic sections. Okay, so a conic, generally, they're all created by a plane intersecting a double-sided cone. And they include parabolas, circles, ellipses, hyperbolas, even single points, lines, and double lines. The last three are considered degenerate because they're not, they're like fringe cases. The general form of a conic is ax squared plus bxy plus cy squared plus dx plus cy plus f equals 0, which is scary looking, but it's really not that bad. Most of ours aren't going to have any b's at all because, well, we'll talk about that maybe or not. Which each of these coefficients is determines the type of conic. For example, for circles, the x squared and y squared have to have the same coefficient and the same sign. For ellipses, they both have to have the same sign but different coefficients. Hyperbolas, x squared and y squared have opposite signs. And then for parabolas, of course, which you should know already, only have one of x squared or y squared. The other one has a coefficient of 0 because, you know, for example, y equals x squared. There's only one squared. Generally speaking, the definition of a parabola is a set of all points equal distance from the focus and the directrix. It's not really how we think of it when we graph them, but it is the technical definition. Now, generally speaking, as we mentioned, a parabola only has x squared or y squared, so if you just got a general form conic, you would know if you're going to have a parabola because there shouldn't be any xy term, and there should only be one of x squared or y squared. Now, vertical parabolas, you're used to doing them y equals a times x minus h squared plus k will be a little different. It'll still require the same skills like completing the square, but our form will be generally a little different. So if it's a vertical, either up or down parabola, your vertex is still hk like it used to be, but your focus and directrix, you can actually find them. The focus would be h and then k plus p. Your directrix is y equals k minus b. Directrix is a line. It'll be a horizontal line for a vertical parabola. In this form, we'll talk about how we use the form. It's just like a slight adjustment to the vertex form of a parabola where we get the thing that was squared by itself. And we'll talk about that when we do the problem. Horizontal parabola just flips it a little bit. The form is slightly the same. Just remember it's y squared instead of x squared. Now you really want to actually see how the problem is done on page 2. So it says, find the focus and directrix for the parabola y equals negative 1/2 x squared minus x plus 1/2. So the first thing you're going to do is the same thing you would do to get this into vertex form, which means you will factor out the a so you can complete the square. So y equals negative 1/2 times x squared. Remember, this is going to factor out of everything. Then it'll be plus 2x. I'm going to leave a plus blank. And we'll leave the plus 1/2 on the outside because we don't need that for completing the square. Remember, by factoring this out, we have to divide it by negative 1/2 to complete what's in the blank. How do I complete the square for x squared plus 2x? It needs to be x squared plus 2x plus 1. Now, what is this plus 1 really? It's really multiplied by a negative 1/2, so it's actually, I'm subtracting 1/2 in order to put that in there. To counteract subtracting 1/2, I also have to add 1/2 on the outside. So this is really y equals negative 1/2. This is now x plus 1 squared, and this is now plus 1 on the outside. So this would be the normal form we used in the past to help us graph a parabola. We know it would open downward, and we know what the vertex would be because they're h and k. We can go a little further though. If we notice from this form, it wants this thing squared by itself. So I need to get everything except for the thing that's squared to the other side. So I need to subtract 1. So y minus 1 equals negative 1/2 times x plus 1 squared. And then I need to multiply by negative 2. So in the end, I get -2 times y minus 1 equals x plus 1 squared. So this is the form that helps us find what, we already knew what h and k were, but helps us find p. Okay, so h here is -1 because it's x minus -1. It's supposed to be y minus k, so we already have a minus, so k equals 1. Now it says 4p is equal to whatever this number out here in front of. So 4p equals -2. So p is -2/4, which is -1/2. So there are my h, k, and p. How do I convert that into my equation? We use this stuff here. The focus is h, comma, k plus p. So the focus, h is -1, k plus p, so that would be 1 plus -1/2. Well, 1 minus 1/2 is just 1/2. And then the directrix is a y equals line, in this case, k minus p. So 1 minus -1/2, which is really 1 plus 1/2, so that's y equals 3/2. So those are our focus and directrix. So if you're wondering what this looks like, I can draw like a miniature picture up here. So we know what this parabola generally looks like. It starts at -1, 1, and it opens downward. So what are the focus and directrix? The focus is a point, it's -1, 1/2, just about right here. And the directrix is a line, it's kind of, we draw it like an asymptote, a dotted line. And any point on the parabola is exactly equal distances from both the closest point on this line and this point in the center. So it's kind of interesting in that way, but we'll do more of these afterwards. Parabolas aren't too bad because it uses a skill you used before, but we'll also talk about ellipses and hyperbolas as well.